You ever open up a Spring Boot project and it's just one giant file with everything crammed inside? Yeah, it might work, but it's an absolute nightmare to maintain. Today, we're going to build a blueprint, the professional way to structure a clean, scalable Spring Boot application. Let's dive in.
So here's the game plan. First, we'll cover the why, the whole blueprint for clean code. Then we'll meet the 3 essential layers that make up our architecture. After that, we'll see how they all get wired together, learn how to handle our data securely using something called DTOs, and finally, we'll watch the whole system come together and work in perfect sync.
You know, the very first step toward writing professional code is getting away from that single-file mess. That's what we call spaghetti code, and we want to avoid it at all costs. The solution is a really powerful principle called separation of concerns. It sounds fancy, but all it really means is that every single part of your application should have one job and one job only.
To make that separation happen, we use a classic 3-layer architecture. The easiest way to think about it is like a restaurant. You've got the controller, who's like the maitre d', greeting people at the door. You've got the service, that's your chef in the kitchen, doing all the actual cooking. And then you have the repository, who's like the pantry manager, in charge of getting all the ingredients. Each one has a very clear, distinct job.
Okay, let's start at the very front door, the controller layer. Its only job is to manage the incoming traffic. It takes requests from the outside world, like a browser asking for a web page. But here's the key. It doesn't do any of the heavy lifting itself. It's basically a traffic cop, just directing the request where it needs to go next.
And if you look at the code here, you'll see how simple it is. That @REST controller annotation, that's just you telling Spring, hey, this class handles web requests. Then @getMapping says, okay, when a request comes to this specific URL /API/students, just run this method. But notice what it does. It doesn't find the students itself. It immediately turns around and delegates that job to the service layer. Which brings us to the application's brain, the service layer. This is where all the real work happens. If you need to calculate something, validate some data, or coordinate a bunch of different steps to get something done, all of that core business logic, it lives right here. This is the chef in our restaurant.
And you can see in the code the student service class is marked with @service. That's the signal to Spring that this is where our business logic lives. The controller calls a method on it, like getAllStudents, and this is where the actual task gets done. In this case, the task is pretty simple, just get the students, so the service turns to our next layer for help. And that brings us to the data library, which is managed by the repository layer. Now, this layer's job is very specific. Its only responsibility is to talk to the database. That is it. It fetches data, saves data, updates data. And this is super important. The repository is the only part of your entire application that should ever talk directly to the database. And this right here, this is where the magic of Spring really shines. We literally just define an interface, student repository, and tell it to extend JPA repository. We don't have to write any actual code to find, save, or delete students. Spring Data JPA, which stands for Java Persistence API, it just gives us all of those powerful database methods for free. It is incredibly efficient.
Now, I know what you might be thinking. This seems like a lot of extra files for a pretty simple task. And for a tiny project, you might be right. It can feel like overkill. But here is the payoff. This structure forces you to separate your concerns, which makes your code reusable, way easier to test, and so much simpler to maintain in the long run. As your app grows, this organization is what keeps it from turning into total chaos.
So that brings us to the next big question, right? If the controllers, service, and repository are all separate and self-contained, how in the world do they actually talk to each other without becoming a tangled mess all over again?
Well, the answer is a really powerful design pattern called dependency injection, or DI for short. You can think of it as Spring's magic glue. Instead of our student controller having to manually create a student service object itself, Spring just provides one. It injects it for us automatically. This is what keeps all our components separate or loosely coupled.
Now, there are a couple of ways to do this. You'll often see @AutoWired slapped right onto a field. That's called field injection, and it works. But the modern best practice, and the way I highly recommend you do it, is called constructor injection. That's where you just ask for your dependencies right in the class's constructor.
So why is constructor injection so much better? Well, for one, it makes your dependencies totally clear and explicit. You can't even create the object without giving it what it needs. This also helps prevent those awful circular dependency errors where Class A needs Class B and Class B needs Class A and the whole application just crashes. But maybe most importantly, it makes your code 1,000 times easier to test.
Okay, so our layers are all connected and they're talking to each other. Awesome. But this actually creates a new kind of problem. When we send data out to a user's browser, do we really want to expose our internal database structure? You know, with all the internal IDs and maybe even sensitive fields? The answer is absolutely not.
This is exactly where data transfer objects, or DTOs, come into play. A DTO is just a simple object. You might hear it called a POJO for plain old Java object that acts like a secure courier. Its only job is to carry the exact data you want to show to the outside world, no more and no less. It's a secure messenger between your app's brain and the outside world. And this example shows it perfectly. On the left, we've got our internal student entity. See how it has a database ID? Now look at the student DTO on the right. Poof. The ID field is gone. We've decided the client doesn't need to know about our internal database keys, so our DTO simply doesn't include it. We are in complete control.
So, how do we get the data from our internal entity over to the safe DTO? We map it. And while there are libraries that can automate this, the basic idea is simple, just like you see here. You create a new empty DTO, and then you just copy over only the fields you want to expose, like the name and email. It's a simple, deliberate, and secure transfer of information.
All right, we've now met all the individual players, the controller, the service, the repository, and the DTO. So now, let's put it all together and watch this whole architecture in action by following a single request all the way through the system.
So here's the full flow, from start to finish. A request comes in and hits the controller. The controller immediately calls the right method on the service. The service, being the brain, knows it needs data, so it asks the repository. The repository queries the database and gets back the raw entity objects. Now, and this is the crucial part, the service takes those raw entities and carefully maps them into our safe DTOs before handing them back to the controller. Finally, the controller returns those DTOs as a clean JSON response. Perfect.
And the best part is that this whole architectural pattern translates directly into a beautiful, clean folder structure. Your project becomes instantly understandable to anyone who opens it. Looking for web code? It's in the controller package. Need to change business logic? It's in service. Database stuff? That's in the repository. It's just so clean, organized, and professional.
So let's do a super quick recap. The controller, marked with @rest controller, is your front door for web requests. The service, using @service, is the brain that holds all your business logic. And the repository, usually with @repository, is the only thing that talks to the database. These are the fundamental building blocks for any clean Spring Boot application.
And there you have it. You now have the complete blueprint. This isn't just some academic exercise. This is how professional, robust, and maintainable software is built. So the only real question left is, with this powerful structure at your fingertips, what complex business logic are you going to build in your service layer first?